Hello and welcome. My name's Caitlin, and today I'll be demonstrating how to model and design single-column steel baseplate connections in an integrated model. That means I'm going to start in a RISAFloor model to design for my gravity forces, carry the lateral force resisting system members into RISA 3D to design for my lateral forces, and then carry the column reactions from both the gravity design and the lateral design into RISAConnection for the final baseplate connection design. Let's go ahead and get started by taking a look at this RISAFloor model that I've already created. It's a very simple model, and I created a mix and match of different column options to show you the different options available for baseplate design once we get into RISAConnection. So you'll have red members designate the elements that are part of my lateral force resisting system, and the blue elements represent my gravity members. You'll notice I have columns that are wide flange columns, I have pipe columns, and I have tube columns here. So I've mixed them all up so that we can see a little bit of everything once we get into RISAConnection. I've also created a second floor, which I'll show you by putting it into an isometric view and rotating the model a bit, just so that we can see the different entry options here in RISAFloor for adding connection rules for connection design onto column members. Because RISAFloor's modeling view is this 2D plan view, you need to go into the column spreadsheet in order to apply your connection design rules. But before we do that here, we're going to start, of course, by creating our connection rules. So we're going to jump up here to the connection rules spreadsheet on the data entry toolbar. This is the same as if you were creating any other connection rules for RISAFloor or RISA 3D. We just have a generic listing here of the available connection types. We just have a basic generic entry for it, and then once you get into RISAConnection, you'll have more options for editing bolts, welds, size of plates, etc. So right now you'll notice I just have these two default moment connections, which are not applicable for our example here today. So I'm just going to click Enter and create a new line to create my baseplate connection type. I'm going to change the label to just call it a column baseplate, and I'll tab into the connection type column and pick out the baseplate option, and then tab again on my keyboard, and it'll automatically update to select the single column baseplate option. That's all I'm going to create today, so I can go ahead and close out my connection rules spreadsheet, and now I can jump into the column spreadsheet where I can actually apply those connection rules to my columns. So in RISAFloor, all column boundaries are defined based on the splice type definition at the ground floor level. So the splice type option here you see in the splice type column refers to how the column is going to be connected to the base. A shear splice type represents a pinned base connection. A moment splice type will represent a fixed connection to your foundation, we're assuming. So because these are required for fixity and stability in your model, you'll notice you cannot uncheck the splice checkboxes here on the lowest level in your model. If I were to flip up to a higher level or higher elevation floor level, the splice checkboxes are unchecked, and you can check them and turn them on and off depending on if you want to add splices to your column lifts. We'll go back down to that first floor plan and take a look again at the splice types. So I've created several mix and match different splice types of pinned and fixed boundary conditions at the base of my columns. You'll notice you have the option to select a default, a moment, or a shear. If you wanted to quickly apply them all the same, you can set up a default. It reads in from the floors spreadsheet, so this bottom option on the data entry toolbar, and you have here a splice type default for each floor level. So you can select that and quickly apply it to all the columns if you know they're all going to be the same. So you can apply that default, or you can come back in here and set it manually to whatever type you like, moment or shear. To actually apply the connection rule, you'll flip over to the next column over here to the right, the splice connection column. And here you can click in any of the drop-down menus, and this spreadsheet will be smart enough to sort out the applicable connection rules to these member types. So these are columns at the base elevation of your floor model, so the only connection type that's applicable is the column base plate that we just created. You'll remember the other two we had in the connection rules spreadsheet were beam to column moment frame connections, so those are not applicable, so they don't show up in this filtered list. So we'll go ahead and apply the column base plate connection rule to the base of all of our columns here on the first floor level. You could click through and do them one at a time, or just select them all in magenta, right click and say fill block, and then I'll type in column base plate, click enter, and it automatically fills them all in. That's going to quickly apply them all to my columns. So now we've applied the connection rule, we can go ahead and solve the model, and the program will go through the member design and solve all of the elements in RISAFloor. It's going to optimize everything for your gravity load combinations. When that's complete, it'll show us our results here. For connection purposes, we're really just looking for the base forces, the reaction forces at the base of our columns, and we're going to carry them into RISAConnection. So we'll go up into the upper right hand corner and click on the director tool, and we'll carry those forces into our RISA 3D model, which will show us the design of the lateral force resisting system. So my lateral frames came through here. You'll notice if I click on the members spreadsheet, once I get into RISA 3D, there's a RISAConnection tab at the far right, and all of my column base plate connections are carried over from where I define them in RISAFloor. I can also view them graphically in the model. I have a toggle option up here for member end display, color display, and I can click on the down arrow and select connection rule to see all of my column base plates applied at the base of my columns. You'll notice I have the different boundary conditions also defined from RISAFloor. I have a fixed condition over here at many of these columns and a few pins over on these at the left side. So again, I've already applied them. I can just go right into load combinations and solve. This will solve all of my lateral load combinations in RISA 3D. Now I've solved for gravity and I've solved for lateral. Now I can carry those column reactions into RISAConnection. So I'm going to again use this director tool to go into RISAConnection. It's going to open up RISAConnection, and it's going to carry over all of the column forces from both my gravity only columns in RISAFloor and the lateral columns from RISA 3D. And it'll bring in all of the reactions from both the gravity and the lateral cases for those lateral columns. So you'll see when you initially come into RISAConnection, you get a summary of all of the connections that came over. They are grouped together based on the designation of the column, be it gravity or a lateral member, and the shape type. So you'll see I have column gravity, a wide flange base plate, separate from, I believe I have it down here over here, I have a column base plate lateral wide flange base plate. It also separated out my square tube sections and my pipe sections here. They're also grouped over here, so you can click through a group at a time. RISAConnection, just like any other connection design or any of our other connection types, will let you make edits to the connection geometry or input options, whether they be welds or bolts, etc., based off of a group. You can select a whole group and make edits to the applicable options. You could change your welding for the whole group here, or I can click on one connection at a time and make edits to that connection. So you can kind of group the design and make a lot of quick edits quickly. When I want to solve, I could also solve an individual connection by clicking on the Solve Connection box. I have a solve group if I wanted to solve this group that I'm selected in, or I'll go ahead and just solve the whole project. That's going to solve all of them at once and give me a quick overview of where I'm starting. The input from the RISAFloor and RISA 3D model just brought in a default geometry of a base plate, so most likely you are going to want to go in and make edits, but you can solve it first and at least get an idea of the design results before you get started. So over here in the Project Explorer, you'll get a pass-fail notification as well as a reference to the load combination that governed and the unity check, the maximum unity check associated with that governing load combination. So if I take a look, let's take a look at one of these failing. You'll notice it's telling me that load combination 17 is my governing failure. I can click open my load combination box here, or excuse me, menu, and I can verify that the program has imported all of the RISA 3D load combinations as well as those from RISAFloor. This is telling us that load combination 17 was the governing, so we can take a look at that here. This is one of our gravity columns that I assigned a simple pinned base reaction to, so you'll notice that no moments came over. The loading is brought over here. It's just a compressive axial force and some shears. We can take a look at the results by clicking onto the Reports tab over here at the left. And you can see that we have a geometry restrictions failure happening here. Everything else is passing, it's just that one. So we can expand this check and get a closer look at what's happening, what might be failing. Looks like there's the plate washers that we have applied are failing. They're not meeting the dimensional requirement here. So you could go over into the connection properties grid over here on the right and find the plate washers. They're right down in here, and edit their width. But I usually find it easier to go back into my 2D view and just click on the washer, and it'll highlight the entry over here on the grid. And you could highlight it, come back over and enter it, or you can just click on it right here in the model view and update it. And we'll notice when I made that geometry change, of course, it got rid of my design results. My previous design results are no longer applicable, so it canceled those out, and it's now showing me an NA and not applicable for the connections that need to be resolved now that I've made edits. So I could go ahead and change any of the other dimensions here. The column dimension, of course, came from RISAFloor, so I can't edit the column information, but I can edit any of the plate, the washer, the anchor bolt information. I could go onto a side view and take a look at the size of my concrete pedestal. I can change the compressive strength of my pedestal depending on my material type, and any of these other dimensional geometric properties. You can click on any of these and change them all in the 2D view. Oops, let me change the size of the plate. Let's just try that. And it'll scoot things in or out depending on what you've entered. So once you've made your edits, you can go ahead and solve again. This time I'll just solve a single connection to save myself some time. I'm still hitting a failure here. Let me increase those washers a little bit more and solve the connection once more, and yeah, there I get a pass. So if I go back into my report, it's already expanded from my previous view, but yeah, now my plate washer with width check is now passing appropriately. I can collapse that and take a quick look at any of the other limit states here. It's kind of a limited view because this is a pinned base condition, so we're not seeing the full bending checks in both directions. But you'll see all of the reference limit states from the design guide. So base plate connection design in RISAConnection is based on the AISC Design Guide 1. I have it here. We're referencing this design guide for all of our design equations. The one edit to that, or the one revision that we've added in order to account for biaxial bending in both directions at the same time, is we're taking into account some design references per the AISC Engineering Journal article called Two-Way Bending of Base Plates under Uniaxial Moment Loading, Alternative Approach. So we implemented the ideas from that paper as well in order to account for biaxial bending. Get back, to my connection model here, and we can take a look at some of these checks. So we have geometry restrictions we already looked at. They're just simple restrictions to make sure that the constructability is all appropriate. There's room for everything, nothing's overlapping. Concrete bearing checks. These come actually from the ACI 318 concrete code. Lateral slip, similarly, from the concrete code. This all has to do with the concrete pedestal underneath the plate, of course, for when the column's in compression. Then we have flexural yielding of the plate itself. all from the Design Guide 1. We have more geometric limitations checked for the plate washers, for the welds, the various welds, and then the weld strength checks down here at the base. Let's take a look at one of our fixed connections. Let's look at a tube perhaps. So here's one of our square tubes. It's also failing. Let's take a quick look at the report. So here you can see we do have moment in both directions, in the strong and the weak direction, as well as some shears and a little bit of axial compression. So the program is going to check the plate flexural yielding about the strong and weak axis in both tension and compression, depending on what is applicable for the overall loading and force distribution through your anchor bolts. You also have anchor bolt tension. There's some uplift at the edge of the plate here, and anchor bolt shear as well. Up until now, we've just been using the default layout. So let me go back into my 3D view, which is 4 anchor bolts. Over here on the top of the connection properties grid, you can edit that at any time. We have options for 4 bolts, 6 bolts, and you can arrange them about the strong or the weak axis, or 8 bolts. You have the option to do that for any of the different column types for our base plate connection. So you can customize that and add in the different layouts for whatever is applicable to your design. You can add washers or not, of course. I had those on before. You could turn them off. And then you can edit all of the dimensions, just the same as we were doing before. So it's very easy to make quick edits to the dimensional properties, very easy to quickly solve and review the results. So you can make quick edits, see what you want to change, see what's affecting the overall pass-fail notification of your connection type, make corrections from there. Everything is very similar to all of our other connection types in RISAConnection, where we've strived to make everything crystal clear. All of the checks are available. All the variables are listed out for you, so you can see the full details of all the checks that we're doing. Thank you for listening. That's it for base plate integration today. If you have any other questions, please visit us at RISA.com or email us at info@RISA.com. Thanks and have a good day.